what function behavior was for the upcoming test? Can you teach me what it is?
It's like how a function behaves.
Guys, relax. I can teach you about function behavior. Let's go.
Top of the morning to you, or more likely it's the middle of the night and you're just studying for your finals. Either way, let's describe what a function is. A function relates an input to an output. That's quite similar to a machine if you think about it. You put something in and you get something out. Now, when you're putting something in, the output is always related to the input. And we'll show you what I mean by that. But firstly, let's go to Mr. Heltzer.
Mr. Holzer, what does function behavior mean to you?
I don't know.
What am I supposed to be doing? I missed the intro.
The classic way of writing a function is f of x equals, and then of course your equation where you will plug it in, but we will talk about that later. F of x is basically y. Let's say that f of x equals 2x. The x is the input, that is what you will put in, and the 2x on the other side is where you plug that x in, or whatever you get for x. Okay, let's jump in and try a problem. How about f of x equals 4x squared? That's fairly simple. Let's say that x equals 2. So f of 2 equals 4 times 2 squared. F of 2 equals 16. How about
What's
that?
function behavior?
The function of a behavior is the behavior of a child that doesn't need to be curfewed every morning before school.
Gabe, can I do it?
When trying to find where the function crosses the x-axis, plug 0 in for y. Let's try it out. Here we have y equals x squared minus 5. Now, when you plug that 0 into y, you will get 0 equals x squared minus 5. Add the 5 to both sides, and take the square root, and you will get x equals plus or minus radical 5.
It's like how they act in public.
When trying to find if a function is even or odd, replace x with negative x and compare if that f of negative x you just created equals f of x or negative f of x. It could be even or odd respectively. Let's try it out. Here's f of x equals 4x to the third minus 3. Alright, now we simply plug in that negative x, and we're going to get f of negative x equals 4 to the negative x to the third minus 3, which is negative 4x to the third minus 3. Now negative f of x equals negative times negative 1 times 4x to the third minus 3, which is negative 4x to the third plus 3. So f of negative x is not equal to either. Alright, so because f of negative x is not equal to f of x or negative f of x, it is not even nor odd. How about one more? F of x equals x to the fourth minus 3x squared plus 7. So let's plug in f of negative x, and actually you'll see that because they're to the fourth and second powers, the negatives will be cancelled out, effectively making f of negative x equal to f of x. So it is even. Now let's compare it to negative f of x, mate. So once we plug that negative in, we can clearly see that it in fact does not work out. So it is not odd, but only even. Alright, next, x squared plus 4 over x to the third minus 4. I'm showing you that both the top and the bottom are respectively even and odd, because usually if that is the case, then the fraction itself will be odd. This fraction being a function, of course. The top negative squared out, making it even and equal to the original, while the bottom did not, making it odd and equal to negative f of x. I'll draw some lines for some visual aid now. Now I'll do the actual problem. So first we'll look for negative f of x, just see what that is. We'll just put that negative sign out in front and not change a thing, that's alright. Next we'll actually do the f of negative x, and see what we get. So we're going to plug that negative x into the x squared up top and down to the x cubed on the bottom and the regular x. And you're going to get x squared plus 4 over negative x to the third plus x. Now, is this equal to f of x or negative f of x? That's the question. And the answer is yes, it is. And I'll draw a little line. Against our wishes, we're now going to graph it. Put all those numbers down there on the xy. And then also note that positive, negative 1, and 0 can't be x because it would make the denominator undefined. Which is 0 for the denominator. So you plug in 2, you get 4/3, because 2 squared plus 4 over 2 to the third minus 2 is 4/3. You plug in negative 2 into the equation, you're going to get negative 4/3. At this moment, you should realize that positive and negative numbers, other than negative 1 of course, are going to be the same. So you only have to do 2 out of those 4 remaining numbers. How joyous. So you realize that 3 is 13 over 24, negative 3 is negative 13 over 24, and you go to 4, and 4 and negative 4 is a third. And here's what your graph should roughly look
behavior?
It's when you're really rude, but you do it well. So people respect you, because, you know, function. So you're stupid, but then you get better at it, and better at it, and better at it. Until you're like the best in the world, but then you just keep getting better. Function behavior.
You're an idiot.
Yeah, but you see, I'm getting better at it. Still getting better at it. Function's still going. Function's still going.
Now we are going to talk about function symmetry. You got even, and you got your odd. Even has symmetry in respect to the y-axis, while odd has symmetry in respect to the origin. So you're going to need x-axis, y-axis, and origin symmetry in your mind for this next part. Alright, so let's just jump right in, partners. So we got y equals x squared minus 6 to the 4th plus 2. Next we're checking for some symmetry, so let us see if there is any symmetry, ladies and gentlemen. So, down south, what we do is we pull down that even y-axis, and we plug in our negative x's, and we get our y equals negative x squared minus 6 times negative x to the 4th plus 2, and we check and it's even. It's terrific. Now we're going to check if it's odd. We're going to put our little negative y's and negative x's in. So negative y equals negative x squared minus 6 times negative x to the 4th plus 2. I'm going to do that out. I'm going to put that negative y equals x squared minus 6x to the 4th plus 2. And you got to see that that negative sign proves that it is in fact not odd. Now we are probably going to go ahead and check the x-axis anyway, because you know it couldn't hurt and it could always end up on the final. Although I doubt it will. Good luck everybody, by the way. So for our x-axis symmetry, we got to do the same stuff. We got to write out our equation. But in this situation, you only plug in a negative y for the other y's. So you're going to get a negative y equals x squared minus 6x to the 4th plus 2. Alright, and now we're going to see if that's equal to the original equation, and it is not. So it does in fact not have x-axis symmetry. Let's do another. Alright, so now we're going to do y equals 2 over x squared. And then we're going to draw down that little x-axis to remind you. So negative y equals 2 over x squared. That's a definite no. Can't see that equal in the original. Alright, now we're probably going to do a little bit of even here. Gonna check out even, which is y-axis. I'll drop both those down to remind you. So y equals 2 over negative x squared. That's gonna square out that negative sign, and so that is a go. So there is even symmetry and y-axis symmetry. So it is even, and it's got y-axis symmetry. Now I'll check the origin and odd. Plug in that negative y and that negative x, and we'll see. And once again, just like the x-axis, does not end up working out. So, nope. We're going to do one more here. Alright. So, we're going to get y to the 4th plus x to the 3rd minus 5x equals 0. That's what we're going to put up there for you. Check out that x-axis symmetry. Going to plug in that negative y. And that negative y to the 4th plus x to the 3rd minus 5x equals 0. Now, because it is to the 4th, the negative will drop out. And we can clearly see that it is, in fact, in use of x-axis symmetry. Now we'll check out our y-axis / even. Alright. So we're going to plug in those negative x's for our x's. So y to the 4th plus negative x to the 3rd minus 5 times negative x equals 0. And we will see, but I'm pretty sure this is not going to work out. So we're going to get y to the 4th minus x to the 3rd plus 5x equals 0. And that is not at all like what we had originally because of those extra 2 signs right there. Yes, sirree. So it is not a y-axis symmetry, and it is not an even function. Now let us check odd and the origin. So we're just going to drop down. So we're going to plug in negative y to the 4th plus negative x to the 3rd minus 5 times negative x equals 0. The y's negative will drop out, but the x's will not. So it is neither odd nor in use of origin symmetry. So let's do one last one. I know it's in you. Come on. Okay. So here goes nothing. So we're going to do x to the 3rd. Sorry, not a great 3 up there. But it's x to the 3rd plus y squared equals 1. Now this one's kind of funny. Oh, never mind. It's x to the 3rd. Which is what we said before. So I fixed that 3. You're welcome. So we're checking out our x-axis symmetry, plugging in that negative y, and the negative cancels out, so it is indeed in use of x-axis symmetry. How cool is that? Next up, we are going to check out our y-axis and our even functionality, which means we'll be plugging in that negative x once again. So x to the 3rd plus y squared equals 1, and we plug in and negative x to the 3rd plus y squared equals 1. But it is not working. How odd is that? So, now, we're going to check out odd and the origin. We got negative x to the 3rd plus negative y squared equals 1. The y's negative will fall out, but not the x's, so that will not work either.
Function behavior. It's how the function behaves. Like if it's cubed, it's if it's identity squared, parabola. Do you just want me to say answer? What? Is that it?
Hey, see, now we're gonna do some graphing to see what the symmetries look like, man. Okay, so the best way to do that is to put out some x's and see what the y's turn out then. Alright, man? So we're gonna use our first equation from before, y equals x squared minus 6x to the 4th plus 2. Yes, alright, so we're gonna plug in our negative 2. We're gonna get y equals negative 2 squared minus 6 times negative 2 to the 4th plus 2, man. Alright, man. So we're going to do all this equation, all this work. And what we're gonna get is 90. So negative 2 is 90. But then you can realize that all the negatives canceled out. So also 2 will be 90, man. Yes, sir. Alright. Yeah, man. Alright, now we're gonna do our negative 1 and our 1. Which doesn't matter which. We realize the negatives don't count, man. So we're gonna pull them out, man. Alright. And we're gonna get a negative 3, as you can see right there. Now we're gonna try out 0, see what happens, man. Alright. And simple enough, everything will drop and we'll just get 2. Okay. So let's put it on the graph. I'm just gonna give you a rough sketch because I don't have all the way to 90. That's a long way, but it's gonna look like this. And you can see right there, man. It's got that y-axis symmetry. It's the same on both sides of the y-axis with all those numbers and those dots right there. Yeah, see, I'll even drop for you right now, man. Alright, man. Here we go. Now let's do the next equation, man. Alright, so we got y equals 2 over x squared. So you draw out, you get your x's and your y's. Negative 2, negative 1, 0, 1, 2. The easiest to find. So you plug them in. Y equals 2 over negative 2 squared. Let's see. And then y equals 2 over 4. So it's going to equal a half. And you realize that once again, negative and positive had the same answer. So 1/2 for each of them. So then for the ones and negative ones, you got 2. And we're going to try out the 0, but I'm telling you there's going to be a problem. And boop, it's undefined. No answer. So 0 is undefined, man. Now I'm going to show you what it looks like on the graph. It's pretty odd looking, but it's not that weird. So here we go. I showed you each thing is going by a half per line. So you draw yours out there. Alright, and you draw your points all around, man. Everywhere, up and down. And that's what it's going to look like. You're going to have lines going up both sides. And you got that x-axis symmetry. X-axis. So now, we're going to try y to the 4th plus x to the 3rd minus 5x equals 0. Just like before. Now you got to set it up as y equals so you can make that y 0, man. Just a lot easier that way. Much easier. Okay, so 3 to 1, 0, negative 1, negative 2, 3. Because I know there's going to be some problems, I'll put some extra points in. It's going to be weird looking, man. I'm warning you. I'm warning you now, okay, man? You got that? Alright, so let's hop on down the road and see what we got. So we're going to use a calculator, I suggest, because it's pretty difficult to do square roots on your own. So I just plugged them all in, and there you have them on the side there. 1.19, 1.41, 0, a couple undefineds here and there. They're pretty freaking looking. Up and down, each notch at 0.2. And to the side, they're going by ones. So I'll put my little dots in there. You see? Man. Alright. Put them in. It's weird looking, so don't get caught up in this graph. I don't think a math teacher will usually give one this tough, man. Alright. Put them in. You got that 1.2, that 1.4 going up. You even got that 1.8 over there, it looks like. Yeah. Alright. I think we're ready to draw it up. Let's see. Come on, here we go. Okay, I'm pointing out all the points. And everything. Here we go. Come on, man. Hurry up. Jeez, some people are just so slow, man. Don't forget that origin point, though. That's important. Alright. So, looks weird. You might have to plug a couple extra points in, man, to figure it out. Don't forget, though, it is plus and minus, man. So that's what it looks like. It's pretty odd. But you also got to do it on the other side, too. Because it is plus and minus, as I said. Kind of looks like a dragon a little bit, like the Loch Ness Monster. Okay, so here we go. I'll put it in. Draw it over there. Sorry, you can probably skip it a little ahead if you want, guys. Drawing it in. Got the reflection of the Loch Ness Monster, and that's how it's gonna look. Pretty odd. I warned you, it was weird looking, man. Weird. Alright. Symmetry. Now I switched this next one up a little bit from x to the third because I want to show you what 3 symmetries looks like on a graph. 3 at the same time, man. So, it looks pretty simple. It's pretty interesting too. So you gotta get x squared plus y squared equals 1. It's a little different. I moved the y to the one side. Rad 1 minus x squared. Once again, it used to be x to the third plus y squared equals 1. But I switched it up because I want to show you what all 3 symmetries look like at the same time, man. So you get x is 0 and y. You put 2, 1, 0, negative 1, 2. So there is no 2. That is undefined. And it's the same for negative 2. Should be the same because it squares out. Okay, let's check out our 1s, our 0s, and our negative 1s. Keep in mind it is plus and minus because you took the square root. Okay, so we got the 0s for the 1s and the negative 1s. And for the 0 we get, it looks like it's going to be a 1. It is a 1. So, that seems pretty simple. But what it's actually going to look like, and you might want to put on more points if you get this, but it's going to be like 3, 2, 1, here comes the surprise. We're going to draw our points in, 1, 2, 3, 4. It is a circle, because circle has all 3 symmetries. You see that? Pretty cool, huh? Enjoy.
What's a function behavior?
Donate blood.
Ladies and gentlemen, boys and girls, welcome to Trigonometric Functions. Now, there are a couple things to note about trigonometric functions. Cosine and secant are even, while sine, cosecant, tangent, and cotangent are odd. So remember that, and I'll write it on the sides for you up ahead. Alright, and of course, even, once again, y-axis symmetry, odd origin symmetry. So that's a lot of what we're going to be doing. I wrote it on the sides there. Let's try, just jump right in. F of x equals tan x secant x. How are we going to handle this? Well, I'll tell you how. We're going to plug in that negative x just like we did before. Remember? I hope you do. Alrighty then, boys and girls. And now, here we go. We got our little f of negative x equals tan of negative x, secant of negative x. Now we know what odds and evens can do, don't we? Evens and odds. Well, f of negative x equals secant of x and negative tan of x. You can do that because they are even and odd. Remember, f of negative x equals f of x for an even, and negative f of x equals f of negative x for an odd. So that's why we did that there. And it makes sense. Now we took out that negative sign from the tangent, just moved it a little bit, and we realized that f of negative x equals negative f of x. So, ladies and gentlemen, it is an odd function, and that's how you do trigonometric functions. Thanks for watching. And if you have any questions, don't be afraid to send them to Siegel98, and that's at Gmail. Thanks for everything, and here's a couple bloopers for your entertainment.
Function behavior.
Well, function behavior is when, I don't know.
What's function behavior, Miguel?
I don't know.
That was cool.
That's enough!